You hear me now? So we have Daniel Wittenberg. Get that right? Look at that. He's going to be presenting on scaling Nagios at a giant insurance company. Dan has been a Unix Linux admin for over 15 years and a NetSaint/Nagios user for almost 10 of those. He's written many custom plugins and event brokers and also contributed patches and updates to many others. He's also an avid open source promoter and uses it whenever possible. So without further ado, here's Daniel.
Well, one of the first questions that people usually ask is how big of an install? Because I'm sure you guys have probably all seen the forums where people are like, oh, I have a large install of like 500 hosts. Okay. Right now what we're looking at is about 36,000 devices and about 1.4 million service checks. With the other updates that are coming, there's probably going to be close to 50,000 devices and over 2 million service checks by the first of the year, with some new labs and stuff that we're bringing on. So it's getting big fast. So hopefully we'll have some helpful advice. Some of the topics that kind of went through is some of the things that we've kind of addressed and looked at, kind of all the different areas. I thought I'd just try to hit as many of these as possible. Most of these we could talk all day on individual items on different things that we've done. So we'll try to kind of get through some of it as fast as possible. And if you guys have questions, just holler. I know some of the performance stuff has been covered in other talks, so we'll kind of jump around where needed. Here's kind of a rough architecture of what we have. We have let's see how this thing works. We have a custom control panel that we wrote that kind of manages the host configs, because all of our configs are, as you can see, it kind of pushes them over into Puppet. And so we needed something that wasn't centric to one single server. A lot of the options and off-the-shelf tools we saw, they assumed you had one server and you were configuring all your configs on that one server, where in our case, we're pushing it to a whole bunch of different servers all over the place. So it needed to understand, well, I'm configuring this service or this host, but this host goes on this specific server and this management server for a reason. So it kind of does some of the back-end work of figuring out which servers need to be put where the load is, so we can kind of pretty evenly distribute stuff across all the data centers. So we kind of had to write our own control panel to kind of manage the whole environment. It also does some interesting things, like you see it's got connections out to all the management servers. It can query using the live status interface to find out what a host is actually doing on the server. It does some various other checks of what the actual management servers are doing, so you can have some idea that the services are running and things are happening like it's supposed to. Then you can see Puppet pushes everything out to all the servers. And then we have basically a Nagios master server. It's just another Nagios server, but it only watches the other management servers. It's pretty much its only task. So he's actually the only one of all of these that's actually still on a VM, because he's only got 33 hosts to monitor. That's also our Splunk indexer. So all the logs from all the activity that happens anywhere all gets into Splunk, so we can do some kind of correlation sometimes, and we can follow the path of a host from the time that it gets set up in an operating system, gets monitoring added to it, all the alerts that it generates, to the time that it gets decommissioned. So especially if you're working with stuff that's in a test environment that may be having weird issues, we can kind of quickly see the whole gamut of where its life cycle has been. We're also running Cacti on our Nagios master, and his only goal is to watch the performance of the management servers. And I kind of went with that outside of Nagios, because I figured if Nagios was having performance issues, the graphs might get off and not be right. So we have Cacti using, it originally was using a CGI that it would talk to on all the management servers, and it would pull the data, but we found that just the overhead from that CGI check was just way too high. So I rewrote it to actually talk through live status to pull all the data. So now it has almost no impact when it runs, but it goes out and gathers all the basic metrics of the command pipes and the buffers and yeah, just kind of the core top half a dozen or so stats that you watch on the master for performance. Hardware versus VMware. One of the first things that when we kind of got a basic infrastructure running, we started looking at where were our bottlenecks, what was going to happen, where would we start hitting problems. One of the first things that we found is that our VM host couldn't handle more than about 1,000 or 1,200 hosts. It would start having issues. So we started doing a lot more in-depth performance analysis. And what we had found, we even got to the point where we had a brand new 32-core ESX server. We vMotioned our test box over to it, which was an 8-core, and we found that even that, it couldn't hold up to anywhere close to what a physical box could. Once we started throwing 1,000 hosts at it, 1,200. I think the next. So this was kind of some performance comparison numbers we went through. So I had the VMware box at first with either 4 and 8 processors and tried different numbers of hosts just to kind of see where our service latencies and the latencies. We were kind of shooting for less than 5 seconds is the high end for what we wanted for latencies. And we were seeing well over that on VMware. No matter what we really did, we got down to very few hosts before we could get the latency number down to what we thought was acceptable. We actually then got a loaner Power Edge, got to do some performance tests on that, and it held up much better. As you can see by the service latency, that even with roughly the same processors and same memory, it was night and day difference between the performance. We actually had, I think we had about 1,400 or 1,800 hosts in the test lab when we had the R710, and no matter what we threw at it, we couldn't get it to hardly change. So there's a huge difference in there. And then what was interesting too is the very last one was we had a whole bunch of these DL380 G4s that are like 8 to 10 years old. We started running some performance numbers on those, and you can see that even the latencies are way better than even what we saw on VMware with an 8-core. And so we kind of started digging in some more, and what we really found is that it seemed to be isolated to the high number of checks that were happening. Just the number of processes that would spawn up to do the check result analysis and the PNP graphing. Every time you forked another process, it seemed to put a pretty heavy load on VMware. So we kind of went back, and what we actually ended up using was a whole bunch of the DL380 G4s. They were laying all over the place, and well, we've got them, we might as well use them, and if we need more, they're sitting on a pallet. So that's why at this point we have about 33 total management servers that do the load, because we figure if we run out, we just add another one. So what we kind of found is that when we were doing all the analysis, that the CPU requirements, it seemed like having more of them, so having large amounts of processors versus very large, powerful ones, seemed to make a lot bigger difference. It seemed like it was able to adapt with all the spawning processes. We also found interesting, we thought we were going to use a lot more memory than we did, but most of the boxes either have 4 or 8 gig of RAM, and we're not hardly using any of it. The Nagios core in itself is really efficient. We used, I think we've got 2 RAM disks set up now, each with 128 meg. I think one might be 64 yet. But other than that, we still have like a gig free of memory. So it's been pretty efficient, so that's been pretty nice. The disk I/O, I think kind of as we saw in the last presentation, that the faster the disks you have. We had a really hard time kind of doing analysis on this because there's no easy way to get a hard set number. CPU, you hit 100%, you know it's 100%, that's it. Where with disk and I/O, it's all dependent on your disk, your RAID cards, the cache. You can't really say exactly what's the maximum I can push. So we kind of set off is to see, okay, if the server's sitting there just kind of idling along, what do we normally see? And then when we see the spikes, trying to reduce those spikes down. So whatever the number is, let's just get it down as low as possible. So we moved as much as we could to the RAM disks.